So we saw these yesterday. Pull the door towards you, and then that'll move it out of the way. Give it a good yank. Yep. Yep. So yesterday we looked at these two, so you can just put your pencil down and sit back and relax. You already have a copy down. You do not need to copy it down again. That's for sure. Pardon? Okay. So you could copy it down then if you want. If I told you not to yesterday, that's fine. But I just want you to watch, or you can copy it down later. It doesn't matter, right? I want you to think about a couple of things. Definitely don't write this down. 3 over 4 all squared. What does this mean? It means 3 over 4 times 3 over 4, which means 3 times 3, just multiply the tops and multiply the bottoms, times 4 over 4, which is like 3 squared over 4 squared. So in this case, it's 9 over 16, but this is the one that we're interested in. 3 over 4 all squared is like 3 squared over 4 squared, right? So what is the square root of, 49 over 64? Liam?
7.
Yeah, do you see the connection? It's equal to the square root of 49 over the square root of 64, just like when we were doing exponents. Square roots really are an exponent, a different kind of an exponent. We just write them differently. In grade 10, at least we do. Okay, so that's actually not that bad. So when you look at this, yesterday we talked about this, but even before we talked about it, this is what I would hope for you to observe. A lot of today and a lot of what we're doing for the rest of this factoring stuff is all about what do you observe in the question? What do you notice? What jumps out at you? What stands out in this question? There's two things. They're fractions, but there's two of them. And everything in both of the fractions is a perfect square. 9, 4, 25. There's two things with a minus sign between them. So even if I didn't know this stuff about square roots of fractions, I would hope to notice that this kind of looks like a perfect square, just it's got fractions in it. Okay, and if you notice that, and now that we've talked about fractions, it's something plus something times something minus something. And what are those somethings? It's the square root of each of those terms. So the square root of x squared over 9 is x over 3. And the square root of 4 over 25 is 2 over 5. You're just taking the square root of both things, whether they are fractions or something else. Okay? Any questions about that? What about B? What did we learn yesterday that allowed us to factor B? Jaden, what do you think? Right, so what's the relationship? When can I tell if I can factor or if I can't? How do I know? Right, not just when it's even, that's part of it, and that's part of the difference of squares stuff. There's a little bit more to it than that. There's a relationship between this exponent and that exponent. Riley? Yeah, well, kind of. 4 is half of 8, so divisible, but in a special way. Exactly half, right? So if this was x squared minus 3x minus 40, yes, factorable, because this is a 2 and this is a 1, and 1 is half of 2. If this was a 4 and this was a 2, yes, factorable. Somebody answer the door. What's up? Yeah. Sure. Okay. What if it was x to the 6 and x to the 3? Yes, that would work because one of them is double the other one. What if it was x to the 5 and x to the 3? No, that's not factorable. you understand what I'm saying? So it has to have that relationship where this exponent is twice that exponent. And then I'm doing this one in this case exactly like a simple trinomial. Two numbers that multiply to 40 and add to 3. What do you remember they are from yesterday? We already did this one, but anybody figure that out, Ineng? So -8 and +5, very good. And then you can just ask, what do I put here to make it work? Thinking like, when I expand, I need to get that and that. And the answer is x to the 4 and x to the 4. And in fact, it always will share that exponent. It will always. But you can always just think like a good strategy in general when you're factoring is thinking, well, how would I make this work? If I was expanding this, what would give me back that question? Good? Okay, with that in mind, take a look at C, see what you think, see what you notice, see if you can get it started. Go. I'm going to give you just 30 seconds or so. Okay, what do you notice? What are your observations? This is brainstorming, folks. No right or wrong answers. If you observe it, it might be relevant to you. It may not end up being relevant to factoring this thing, but hey, it jumped out at you, so it might help, Liam. 6x cubed. So what do you mean by that? Like, is that important? Yeah, it doesn't match with the squared. Like that thing we were just talking about, this one doesn't work for that. Good observation. That would have to be a 4 and a 2 to share that. Good. Tara. So what do you mean by that? Well, what? Yeah, like what do we call it? We have a word for this. Ziggy? It is factorable, that's for sure. What kind of factoring? Yeah. It's got a common factor in it of 3x, which Sarah already told us. It has a common factor in it. So yes, so you got to common factor that out first. And then and this isn't factorable any other way. This only has a common factor right now. But when I common factor it out, then we're going to look again and see if what's left is factorable. So give that a try. Say that again. Of course. Did you get 2x squared minus x minus 15? Just for a minute, let's sit back and reflect on how much easier that is to factor than, like if I didn't common factor out the 3, and maybe I noticed the x, because you can't do it with the x in there, you'd have 6x squared minus 3x minus 45. That's a hard factoring question. Because 6 has a bunch of factors and 45 has a lot of factors. This is an easy factoring question, I think. 2x squared minus x minus 15. So factoring out that 3 made a huge difference. So anyway, go ahead and try to dance with that one. All right, take a look. So that's what I got. Does that look right? Might as well check, right? Let's check. How would you check? This is how I would do it. 2 times x is 2x squared. 5 times negative 3 is negative 15. Awesome so far. Smile twice. That's negative 6x. That's positive 5x. Negative 6 plus 5 is negative 1. So I checked it with everything. So that's good. So I'm right. What if I had these signs backwards? A bunch of people have asked me the last couple of days, like this morning, somebody asked me right before class or during class, whatever, or people were asking, so what if you, like, how do you figure out the signs? Well, if I just stick in a couple signs and then smile twice to check, and if it doesn't work, then you flip them. Like, if you really get it, you can figure it out, but really it's a guess and check method. So I would do this and I would go, okay, so that's positive 6x and that's minus 5x. 6x minus 5x is positive 1x. Whoops, that doesn't match. So then I would go back and I'd flip them. So this one's plus and this one's minus, and smile twice again to check and see that it's right. That's how you figure out the signs, in particular in a complex trinomial. That's how you do it. Guess and check. Educated guess if you can. Okay, 2 more questions. These are quite tricky ones. But this is the kind that pushes our understanding of mathematics in general and algebra in general. Really worthwhile. Again, a lot of you are going to, for the first time, go like, whoa, I don't really know what's going on. But trust me, you practice a little bit and then you do get there. There will be, I can tell you there'll be 1 or 2 like this on the test, right? And they'll be only worth a few marks, but some people will get them like they're doable for sure. Okay? It's not beyond what we're capable of doing. And like I said, these ones push us a little bit more. And the hard ones are sometimes worth doing because they just make everything else easier. And then when you get the other ones, you're like, oh, this is easy compared to those hard ones that I only kind of understand, right? So that's another reason why it's good to challenge. So what do you notice about this before we get started? Does anybody notice anything? I mean, I know you notice something, but what stands out? What do you think? What goes through your head? Alan?
The -4.
How's that?
Because I feel like it's very small. But I mean, couldn't you just do this and then do common factors and just add them?
If there was a common factor, but in this case there isn't.
I mean, let's say if you do double that, then...
Oh, could you expand?
Yes.
Yes, you could, but that's not what we're going to do. But I'm more curious about the -4, what you think about that. Or anybody else, can you add on to that? What does that look like? Liam?
Whatever you get in your final sum, then you just subtract 4.
If I was expanding and simplifying, yes. But this is a factoring question. It said factor. It's not like what we did on the quiz. It looks like what we did on the quiz. It looks like you're supposed to expand. But the instructions said factor. It kind of looks like it's already factored, but we can actually factor it more. Dylan, what do you think? No, that's not fair. So what you might notice, once it's pointed out to you for the first time, is there's 2 things here. There's one thing. It's got 2 things inside it, but if you think about the binomial, it's one thing minus another thing. So it's kind of like 2 things. And that's a perfect square. Is that a perfect square? Please say yes. It's something squared. It has to be a perfect square, right? What's 5 squared? 25, which is a perfect square. What's 7 squared? 49, which is a perfect square. If you square something, that result is a perfect square. So x minus 1 all squared isn't the same kind of perfect square as 25 necessarily, but in algebra, it's a perfect square because I can take its square root and get something. So this is a difference of squares with a binomial in it. Very different. You may still not see it, or you may believe me and be like, I kind of understand what you're saying, but I still don't really. So let's try this. What if I do this? Let y represent x minus 1. What if I do that? And I write it like this, y squared minus 4. Can you factor that? Okay, do that quickly. I know you can do that. What does it equal? Somebody tell me. Y plus what?
y plus 2
Yeah.
and y minus 2.
Right? Right? Everybody knows that? Y plus 2, y minus 2? That's easy. Oh my gosh, sir, that was too easy. We did that yesterday. It's so easy. Difference of squares. Except it's not y. Remember, we replaced the x minus 1 thing with a y. So this isn't finished. We have to go back and answer the actual question. So I'm going to sub x minus 1 back in. So this is like something plus 2, something minus 2. And what's that something? It's not y, it's x minus 1. And then, yes, I have to finish this. X plus 1, putting the negative 1 and the plus 2 together, and x minus 3. Here's why this pushes our understanding of mathematics. What does this line up here, what's it saying? Something squared, whatever it is. It could be 2. It could be 3. It could be 10. It could be x minus 1. Something squared minus 4. There's no rule that the something has to be a single variable. It could be anything. An expression, picture of a flower, squared, minus 4. Right? Like, it's anything. That's what we're talking about in mathematics when we're talking algebra. Things representing other things. So this is in no way different from that. Something squared minus 4. Something squared minus 4. Something plus 2, something minus 2. Yes?
How did we got the answer like x plus 1 and x minus 2?
I just collected my constants, like terms. Negative 1 plus 2, negative 1 minus 2. That's all. All right. Try another one. This is the same idea. If you don't think you can do it your own, that's fine, but look at it, think about it, see what you think. What does this look like? What do you think? Similar to the one we just did? Okay, so put your pens down for a minute and watch. This is like something squared plus 7 times something plus 12. So if I do the same trick and I go let y represent, in this case, x minus 2, it's not always the same thing, right? It's whatever's in there. Then doesn't this become y squared plus 7y plus 12? Doesn't it become that? Can you factor that? What's the factored form of that? Rachel, do you know what it is? Two numbers that add a 7 and multiply to 12? What? Yes, you do. Give me a break. Rip and Preet? Y plus 3 and y plus 4, 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. But it's not y. It's x minus 2. So it's something plus 3, something plus 4. And what's that something? X minus 2, x minus 2. So x minus 2 plus 3 is x plus 1. X minus 2 plus 4 is x plus 2. These will actually all work out the exact same answer if you expand and simplify, but it takes a lot more time, and there is an understanding of algebra that you miss if you do it that cheating way. And if you cheat on, that's not really cheating, but if you cheat on everything, like if you're always doing things the slow way and the long way, then you end up running out of time on tests, and don't make the connections that make our life easier in mathematics. Okay, I'm just going to show you one other way. So this is how I would do it. Like, this is how I would aim to do this eventually. You don't have to let y represent. Like, you don't have to do that. Maybe do it that way at first, but eventually we get to the point where you can just go like this. So this is something squared plus 7 something plus 12. So I can see that it's a simple trinomial, two numbers that multiply to 12 and add to 7. So it would be plus 3 and plus 4. Whoops. And then I would just say, so, and what is that something? It was x minus 2 and x minus 2, right? That's like my y. Like in my head, just think about that as my y, my thing. Okay? And then x minus 2 plus 3, x minus 2 plus 4.